All right, good morning, everyone. It's a pleasure to talk today at the OpenMod workshop, and I will be talking about data-driven demand estimation in electrification, especially focusing on the needs for harmonized data sources and a potential application of this approach using basic machine learning methods to enhance rural energy planning. This is one of our recent initiatives from our energy modeling department at Politecnico di Milano, and that recently has specialized in off-grid electrification energy planning, among very other topics. And we have also a comprehensive model, advanced model, optimization open source model for sizing and dispatch in mini-grids in rural application with graphical user interface, detailed documentation, and several advanced features. So do not forget to visit our poster so we can discuss a bit about this. So in the context of off-grid electrification, mini-grids stands out as a viable economic solution both for rural and urban context, but the design of mini-grids are still highly dependent on load demand data. Accurate load demand data. And this is a big challenge because data collection in rural areas are, of course, complex and expensive. And usually there is a lack of persistent and reuse of this data among various entities, so resulting basically in non-harmonized data sources. So this work, here it's presented an approach we have implemented. So we started with a comprehensive literature review, identifying the most influencing classes, driver classes for appliance ownership forecast. And then here the harmonization comes into the play because we have implemented this integrated, coherent, grid-like database that integrate drivers and appliance ownership data. And this approach allows people for comprehensive data integration because new data sources can enrich the databases without affecting the overall architecture and structure, setting it apart from online existing databases. And of course, it's a robust user-driven data uploads methods for these kind of platforms to analyze and store this kind of data. So the process involved, this database has been populated through several different strategies. We carry out different interviews with relevant stakeholders in energy sectors. We collect data for related to existing communities gained electricity access recently, and also mining geo-referenced database. Identifying at the end 60 potential important drivers that can affect and influence the appliance ownership in low demand in this kind of context. Such as technology supply, socio-economic factors, past demand data, dwellings characteristics, and so on. And the process involves Python for standardize the format for analysis and QGIS for geo-reference data analysis and spatial analysis to enhance granularity and utility of this data in the database. So this database has, at the end, informed to a prediction algorithm based on logic and regression methods for several different models for appliance ownership, each of one specific specific appliances to predict, basically, based on these drivers, the appliance ownership in the future. So this is a robust predictive algorithm and an interesting approach of this coherent and new database to collect low demand data. So we think that this could be a valuable work and to be also explored in the future. So thank you for the attention. I hope that these ideas spark your interest, and we can further discuss it at our poster with also our model. Thanks.